In this video, we're going to talk about the control system for the layout and some of the other accessories and little assists that go along with it. I've been using Digitrax on my railroads now for about 6 years, and I've been pretty satisfied with the system. No real complaints apart from certain recent redesigns that I would prefer they had not done, probably just a personal issue. But I have continued to build on what I had initially acquired the last time I talked about using that system. The other thing I've done is build on some ideas regarding manual control panels and the computer controls that help bolster that system, and I've also expanded on that. So let's go around the railroad and take a look at what I've done. So none of this model railroadiness is going anywhere if it doesn't have power. So it all actually starts here. When this was laid out, I included provision to have a dedicated layout breaker. So this little 15 amp circuit here is solely responsible for all of the power that goes to the layout itself. The command station, boosters, power supplies, auxiliary power supplies, it's all fed from that one breaker. And trust me, it's not hitting it very hard. So the next stop on this power trip is at the command box. And what I've done here is I recycled some pieces from a desk I built a few years ago, and I've since retired that, and added to that a couple of standard rack rails for 19-inch rack mounted equipment. For the power input, I have this rack mounted power conditioner slash power strip, and it's got a circuit breaker in it. I bought a couple of rack shelves that I lined with plywood so that I had a good mounting surface for all the Digitrax components on this shelf here, and then on the lower shelf I've got my auxiliary power supply. And there was another power supply, my old one, the first one that I built, and here's what remains of it. I looked this thing up, and it's over 20 years old and only good for about 200 watts, and came out of an old 2003 Dell. Dude, you tore apart a Dell. I think it's time to retire this one. The one that's in there now is a newer 430 watt power supply that I got from Micro Center, and I got this little breakout box from Amazon. So that simplifies all of that, and it has more than enough power to run all the accessories on the entire layout. I was going to have separate auxiliary power supplies for each level. That turned out not to be necessary. So the space that's been left open by that other power supply, having come out of there, can now be filled with another Digitrax booster, because I'm thinking of turning Rice Yard and the North End Staging Yard into their own power district, because there is a lot going on there with the locomotive facility and the number of things that can be happening in those two areas simultaneously. So I feel like they warrant a third power district. And then that takes some of the weight off of the other two power districts that are feeding the rest of the railroad itself. Now let's talk about the Digitrax components that are in here. On this first shelf, I've got the PS 2012 power supply, and one side of that is feeding the DCS 210 command station and a DB 210 booster. And those are Power District 1 and Power District 2 respectively, and also lower level and upper level respectively. The lower level and the upper level, in terms of the electrical load being put on this, are splitting the whole room helix more or less between the two of them. So the separation between these two power districts is actually in the middle of the helix. Now in terms of the power output, I have the main bus wires coming out of each one for their respective levels, and I actually have run that main bus all the way around each level, so that even though I've got a block detection system here which splits up the main line into all these little detection sections, there's still that consistent main track bus running through the layout, so that anywhere I need to tap into track power, whether it's for the DS52 stationary decoders, or maybe I have some siding or spur track that doesn't necessarily need to be in the detection system, that can be fed off of that main bus. Kind of like the wiring in your house, there's always some place you can plug into, right? So this kind of functions in that same way for each level of the railroad. And of course, there are copies of this that run out to the block detection cabinet so that that side of the power can be fed through those sections, and thus the detectors can do their work. Now, speaking of the detectors, I built this little box right here, and that holds a pair of BDL 168s. Again, left side lower level, right side upper level. Between the two of them, I have just enough space to hit all of the mainline sections that I want to detect, and the three most important sidings that would require some level of dispatcher control and thus detection, and help the signal system function the way it's supposed to. This is going to be a theme throughout this layout, where I take components like this and mount them in their own little cabinet so that I have ease of access. If there's a maintenance issue, if something starts smoking, it's not hiding under the layout where nobody can see it. It's right out here on Front Street. And I've been referring to these things as nodes. That may or may not be the appropriate term, but that's what I call them. Now let's talk about the Loconet. You'll see as we go through this video, a number of components are connected with a white Loconet cable. And those are the stationary components. So the block detectors, command station and booster, and stationary decoders like DS64s and 74s are all connected on the white bus, so to speak. Those are attached to this Loconet repeater module. So what that does for me is takes all of these stationary objects and puts them on a protected Loconet bus, so that if there's any fault in the bus vis-a-vis the UP panels, that can be dealt with by the repeater module. And of course, that module also breaks out a second Loconet bus that I use exclusively for universal panels and anything where you might be connecting with a tethered Digitrax throttle. Now, universal panels and the like are all on the black bus. Anything that says universal panel or UP on it, other than Union Pacific stuff, is connected over a black Loconet cable. And that helps keep that system organized and separated and all of that happiness. And occasionally you'll see something like this silver gray wire. That usually steps in when I've run out of one color or the other and I just need to wire the thing up. And so there's a couple of those things living on this system. When I built the original control panels for Rice Yard, that was all done with the understanding that it was going to be part of a portable Fremo setup. So those panels were embedded in the fascia with the understanding that that was going to have to be moved around, and generally I was hoping that being behind the fascia like that would also help protect them at least a little bit, since nothing would be directly poking out. So that influenced the original design and layout of the control panels that I thought were going to go into further editions of that. On the permanent home layout like this, number one, I didn't want to go through the work of trying to cut into the fascia for those areas, and it turned out that some of the panels needed to be larger than the initial size dictated by those 4x6 plastic placards that I was using that I got off of Amazon. So I bought some larger versions. I've got 6x8 and 5x7s for panels like this that have a lot more going on and thus require that extra real estate in order to operate. So this, for example, is the panel for South Denver. Also, because of the increased height of the railroad overall, that left enough room underneath the fascia level where it would still make sense to mount a control panel in a comfortable location. And I came up with a modular design using these little cabinets that I built that not only allows them to be used on this railroad, but if suddenly it's layout kaboom and I do a different project or I have to move or whatever, no problem. I can pack these panels up separately after I've detached all the wiring and everything, and probably recycle them into the next project. And it's good to have a standardized design for everything. It keeps everything familiar. You're not having to answer new questions every time you get to a different control panel. I tried to bake that into the design of it. Part of the standard I came up with is that you have the control surface on the left side, and then some accommodation for a Digitrax panel, or there might even be room for a second one here if there was some utility that another panel would provide, such as like optical detection, or we just need more jacks in this area, who knows. But that space is there just for that. I feel like that works in the sense that when you're working in an area where you would need access to one of these control panels, you also have some place where you can plug in a tethered throttle should the need arise, and not be too far away from that in the work area that you're operating in. The great thing about it is There's enough of these around the railroad on both levels that you're never very far away from an ability to plug into that system. Now, of course, for all of my talk about standardization, this one panel actually does represent a bit of a break from the usual design in terms of how the components are laid out on the panel. And that's largely a function of the fact that there's so much going on in this junction. I didn't want to put a ton of little track position LEDs in here. So there's a simpler system just for this area where, depending on which one of these lights is lit up, will indicate whether a particular switch position has been thrown or closed. And in the case of this one, that red light is for the main double crossover. So that's conflicting, and then that is bypass. And all of this will eventually be labeled so that you can look at it and kind of have an understanding of what's going on, even if I haven't read you into the project yet. Now, on most of these panels, the expectation is that the dispatcher has ultimate authority over what's going on, because all of these panels are designed to control mainline switches. The stuff that's on sidings and spurs far away from the main line, those are all done using manual Caboose Industries ground throws. Now, there's another type around here, mostly because I didn't want to run through a ton of Digitrax stationary decoders. I've come up with these key lock switches, and these are done using simple relays that I got off of Amazon, and they function a lot like the manual input controls on a DS64 or 74, where you push the button once, it flips the relay one way, push it again, it flips it the other way. The expectation here is that these are switches mostly on the, almost entirely on the lower level, I think, where the operator has the discretion over the position of those switches, provided that there is no conflict on the main line, and that is of course cleared by the dispatcher before he begins operation anyway. When you're working in these areas, you have this little switch key, and now I've locked that switch. You can see the indicator light winks off. If I leave it in that position, you pull the key, walk away, the main line is secure. And when you unlock the switch, the indicator light on the button comes on. Then you can freely operate those switches as you need to in order to do your switching work, and then lock everything up and close everything for the main line. Now, there's another side to this, because I don't want the dispatcher to be completely in the dark when all of this is going on. Now, dispatch has their own little analog box right here that basically has all of the buttons and switch positions that they correlate to right here in front. So when a switch has been unlocked, the same indicator light that shows up on the panel also shows up on the dispatcher's analog panel. And then when a switch is set against the main line, a red indicator light pops up telling the dispatcher that a switch for that section is set in the main, or set against the main. And of course, dispatch can always clear that with the touch of a button. So for example, this switch here for South Park Junction, for whatever reason the operator has finished their work, locked the switch, but left the switch set against the main, for which they will be reprimanded when they return to the yard, or worse. No problem, in an emergency, the dispatcher still has full control of those switches regardless of the key position. So a touch of a button, now the switch is set back to the main line, and that clears the warning light next to it. This little red button here is for the exclusive use of the dispatcher, and that's to control the one switch at the south end of this Burnham staging yard arrangement. I didn't really have space in the decoder to include that switch in the interlocking at South Denver. So this runs another one of those little flip-flop relays. And so whether the ring light on the button is lighted or the indicator light next to it is lighted, that tells whether or not the switch is either closed or open, or normal or reverse, straight, diverging. You get the idea. And that, of course, has a red ring light. These have yellow ring lights, and the ones that are computer controlled have blue ring lights. And I've got a couple with green ring lights, and there is an actual logic to this little color coding that I've got here. The logic behind the color coding system here is based on who really has ultimate control of that switch. So for example, this simple little panel here, which I call the green-eyed lady, this controls a pair of switches that are located rather inconveniently right in the middle of Rice Yard. And while I was able to do the first of those 3 switches with a caboose ground throw, and it's relatively easy to reach from this particular spot, the other 2 are kind of buried, so I put those on tortoise machines right away, and this is the control panel that finally operates those things. And it's pretty simple. You know, the first switch is on a ground throw, the second switch is here, the third switch is here, kind of matching their same position on the railroad. And they have green buttons because green means go, right? Anybody can use those switches. At least anybody who's operating in this position can use those switches. I don't want randos just walking in and mashing a button. For example, since this is the Rice Yard Yardmaster position, the individual can control those switches, and whether they need them or whether they're doing it for the sake of the train master on the other side, who also has responsibilities switching the southbound yard there. Either way, there's a way to use those green buttons, and I haven't placed any restrictions on them. Yellow button panels such as this one are, as I had pointed out earlier, more or less at the discretion of the on-the-ground train crews, provided the dispatcher has not given them any specific conflicts to avoid. And those are the ones that are operated by a key switch, and we all saw how that works. The blue button panels are more or less computer controlled and therefore much more at the dispatcher's discretion. In fact, the only reason they're all lit up right now is because when I'm running the railroad by myself, I don't want to have to keep going back to the computer to activate a particular control panel. I just leave them on all the time. During an operating session, those would typically be turned off and only switched on in the appropriate section when a train crew needs to use that for switching or something like that. Otherwise, those switch positions are under the exclusive control of the dispatcher and run from the computer. And finally, the red button, the one and only red button that controls a switch on the layout, is off limits to everybody but the dispatcher. Red means stop, so don't touch. Very simple. So those are the 4 colors of buttons that I use on this railroad and what their colors mean relative to their position. One of the things I wanted to include for the dispatch area, besides the main computer screen for the computer they're using, is to have these kind of side windows that give the dispatcher, who is also the South Denver tower operator, a view of the track and switches at South Denver, so they have a visual verification that a switch has actually thrown to the correct position, and they can watch as trains go through that area and observe that there's no derailments or faults or anything like that. Now, these used to be smaller 7-inch screens, but that was entirely too small for anybody to see anything effectively. So I've replaced them with these slightly larger 11-inch screens. And so I decided to repurpose those little screens to some other use. Now, here in the assistant mole operators area, I've made this little tiny desk just to give them some flat space to work with. But there's also a little monitor that's connected to a camera that looks down the other side of this track that leads down to the north end staging yard. So as trains disappear into their little hole, the operator here can verify that they're headed to the correct track, that the entire train is still moving one end to the other, and that it's not crashing into anything or derailing or what have you. So there's one for this position, and there's one on the other side of that area, so that the main mole operator can also do the same thing and make sure that trains are actually cruising into the north end of the yard and not breaking in half or hanging up or anything like that. It's always good to have some visual verification when you've got blind spots like that. And this one is doing double duty because you can also see where the main line, after it goes over Mississippi Avenue and starts climbing up through the single turn helix, before it gets into that hard to see and hard to reach trackage, you can verify that also a train is not coming off the rails or splitting in half or anything like that. The final peeper cam is right up here near South Denver, and this looks at the far end of the Burnham staging yard, so that as you're bringing in a Rio Grande train off of the main, it's of course going to disappear around the corner And one way or the other, you're not going to be able to see it after a fashion, at least not the front end. And so to ensure that you don't go crashing into the other side of the backdrop over there, I've installed this little camera so that as soon as you see your locomotives poke out on the bottom of the screen, you've got enough time to kill the throttle, and then you can make the mad dash up to Burnham to finish yarding your train, or hand it off to the dispatcher, who in his spare time can be the Burnham staging yard operator there. Now, the original wiring for this end of Rice Yard used to be contained underneath the table itself. I've since decided to move all of those components over to this little node cabinet here. So you can see we have the DS64, we have the DS52, which controls the relays. I've replaced the Atlas snap relays with some units I found on Amazon. And what this helps do is keep all the wiring neat and organized and grouped together in the same area where certain related components need to be connected to each other anyway. So rather than spreading all that crap out under the layout where it's hard to get to, hard to see, and maybe not as efficiently put together, all of this is right up front. And I'll be making little cabinet doors to kind of keep the dust out of here. But that's the basic format for these lower level node boxes. I've got 2 of them for the computer control and 2 of them for the regular relay controls. There are also 2 more computer node cabinets for the upper level. This one controls the Overland area, General Ironworks, and one of the turnouts at Littleton, because I've got 3 things over on this end of the railroad that need controlled and 5 things that need controlled over at Littleton. I've altered the layout of these cabinets slightly because the DS74 decoder has a slightly different design in terms of how it's connected to its outputs and inputs. So I ended up coming up with this system, and it works fine. You know, there's still plenty of room to get in there. The wiring is not quite as neat as I would like it to be, but I just wanted to get these things up and running, and if I really want to pretty it up later, I can spend a Saturday doing that. So a word about the use of the term nodes when it comes to these little cabinets that I built. All of this was inspired by a model railroader named Rob Bennett. Not only has he built an excellent looking model railroad, I mean his scenery is top shelf, but he also has a playlist describing layout wiring and the use of CMRI, the Bruce Chubb Computer Model Railroad Interface, and he uses various components of that system and has organized them into these areas called nodes. Now, the reason they're called that is because that's what the CMRI system calls them. These are the cards and components that interface computer commands with actual electrical layout functions like switches and signals and block detection. So I borrowed the node term from that. So that inspired me to do what I've done, grouping related components together into these little cabinets and then placing them strategically in the areas where they're going to control those functions. Now, another thing about my system is that it's kind of a triangular system. So one end of the triangle is the node and all the components that live in there. The other part of the triangle is the control panel and the functions that it inputs to the node. And then the third part of the triangle is the on-layout components such as switch machines or signals or what have you. And those things either take information from the control node for what they're supposed to do, and they send feedback to the control panel for position indicator lights. So that's how that little triangular system works. Now, another thing about the use of this sort of triangular system and having these control nodes and panel boxes and what have you is that I can localize a lot of the more complex wiring in those areas on the workbench or right there where I can reach it very easily. And then the stuff that's on layout is just a matter of connecting wire runs between those individual components and the places where they need to be landed, either in the node or in the panel. And I've been doing this using an assortment of sprinkler system cables. And these are usually grouped 5, 7, 8, 9, 10, a certain number of 18 gauge solid wire strands. This helps keep things nice and clean, and they're almost universally sheathed in a black outer jacket, which matches my fascia. So that helps blend the wire runs in a little bit where they have to be exposed out there on the front. When I have to break them out underneath the layout, you just strip off the sheathing on the main cable, and then you can break out those wires and kind of color code everything so you can land everything in the appropriate spot. So I think that just about covers everything I wanted to talk about in terms of the control system on this layout. There are other elements that will eventually be added, such as the signal system. I haven't bought a single component for that yet, other than the block detection. And getting Loconet fast clocks in here, and trying to integrate all of that with JMRI and make it make sense and make sure everything works. And I'm still kind of a newbie when it comes to that stuff. So that progress will happen over time, and then when I'm ready to talk about that and put it out there, then I'll have the show and tell and the layout update for that. So until then, I'm Mike Lindsay. Thanks for coming out.